Welcome to Deer University, the podcast of the Mississippi State University Deer Lab. I'm Bronson Strickland.
And I'm Steve Damaris. We're both lifelong hunters, deer biologists, professors of wildlife management, and co-directors of the MSU Deer Lab. We explain the latest research, including our own work and that conducted elsewhere.
So if you're interested in deer biology and management, this is your podcast. Every decision you make is a step in your management program, and we give you the knowledge to make every decision count. Welcome back to the Deer University podcast. We are once again very fortunate to have Mark Turner, now Dr. Mark Turner. Congrats again, Mark. Glad to have him to join us. Mark is going to follow up with his research. We in the previous episode, we spoke about a relationship that he was able to quantify in a predictive equation relating doe body weight to mature buck antler size, and the reason for the existence of that relationship, as well as the predictive qualities of it and how you can use it. Today, we are going to focus more on the plants. We're going to focus on nutrient requirements of deer, how native plants are able to fulfill this requirement, and some of the observations he saw on properties, data collected, and what he learned. But before we jump to Mark, let's provide our very first rambling opportunity for the great Steve Damaris. Steve, welcome.
Hey, there are several significant songs in our historical backgrounds, and different aged groups have different songs, and the rambling man, rambling man, yep,
ramble on,
rambling rose, yeah, ramble on. But anyway, rambling is not a bad thing as long as it's in the right context and not excessive. But I guess if it's rambling, then it is by definition excessive. All right, well, I'm going to stop rambling about the concept. The importance here, last episode we were talking about the condition indices, doe body weights. Did they represent antler size in bucks? And those are metrics of the herd condition specific to an age and sex class that ideally is going to tell you something about the condition of the population relative to the nutritional carrying capacity of the habitat. Are you able to provide nutrients, a variety of different types of nutrients at the right times of the year in your habitat to support the growth and productivity needs of the deer population? And we measure those things just like we do. Oh man, you probably remember that great analogy I used about index funds and stock market.
How could we forget?
Yeah, well, it applies here too, because we need to monitor aspects of the habitat to see how that habitat might respond to improvements in structure and composition that we use prescribed fire and timber harvest and thinning operations generally, and timing of fire, growing season, warm season. A lot of these metrics or these habitat management methods we monitor them using these metrics. So we have to understand the requirements of the deer population for specific life processes. And I like to use that life process because a doe has different life processes than a buck, and their nutritionally demanding times of the year differ because their life processes differ. So when we think about habitat quality, we have to think about the time of the year that it's being produced relative to the needs of the animal to fulfill their life processes at that particular time of the year, at that given age of the animal. Is she lactating, or is she going to breed for the first time? The demands are different, or the life processes are different, and similar nutritional demands though. So what we're going to talk about today, Mark, I think is some of the nutritional requirements for deer, so we can better understand what they need and when they need it. And then we'll talk about what can we measure in the habitat to give us an indication of the ability of the habitat to provide for that animal. And one of the things we've used historically, something called a nutritional carrying capacity index or estimate. And we look at the amount of forages by forage class minimally, and preferably by forages that are used by deer, either reliably or preferred, and then look at the nutritional availability of protein or phosphorus or a variety of minerals or even energy. In some places, it's really, really critically important. We generally don't worry about energy as a nutrient limitation here in the Southeast, but it can be, and it's certainly driving a lot of factors like out in West and South Texas. So enough rambling. We have to understand what's happening in the habitat to evaluate whether or not that action that we've implemented is an improvement or not, and when does that improvement kick in, how long does it last, so that we can then time another impact sequentially to keep that positive effect evident in the population so that they can fulfill their genetic potential for the age and sex class that they are, where they're being harvested and monitored.
Absolutely. Yeah, because we something that we use all the time. You kind of hit on there just a little bit. That nutritional carrying capacity is something that we as researchers use all the time. Something that I've done and others here at the University of Tennessee, as well as some of the work that y'all have done, looking at things such as food plots or prescribed fire. Disking treatments. There's all sorts of various treatments that can be implemented to improve habitat and specifically forage availability for deer. But if you just look at the weight of food that's there, you're really kind of missing part of the picture because oftentimes, especially in the deep South, you'll hear folks say, "Well, there's plenty of food for deer," and that's not incorrect. There are lots of plants that deer will eat that deer are not starving to death in South Mississippi, for example, or even in South Florida. There are plenty of plants that are able to meet those minimum what we would call maintenance requirements, which are just the food that essentially allows them to stay alive. But what we're really interested in is how much food is out there that's letting them either express their maximum potential in antler size, or specifically allowing a female to produce enough milk for her fawns to survive. And so those are really kind of the key things that we think about. And so we incorporate both the amount of food as well as the quality of those food resources in this thing that we call nutritional carrying capacity. I don't think we have to dive too deeply on that, but essentially the nutritional carrying capacity requires you to consider the minimum requirements of a deer to meet some life history process, whether that's antler growth or lactation. And typically we use nutrients, and especially in the South, but also elsewhere, we really focus in on crude protein and phosphorus, because at least historically, those have been the things that most people have pointed to as being the most limited in most vegetation types across the distribution of deer.
So, Mark, people probably heard your layout and your study design in the previous episode. So let's just go through that very, very quickly. So you sampled properties, again, from the Deep South, the Gulf Coast, Florida, all the way to New York, Minnesota, all the way west to Kansas. And you went property by property during the growing season. So then you were able to go and collect plants, and these are plants that there is some well-documented evidence that it is a bona fide deer forage. And you collected those plants, and why don't you discuss, again, we don't need to get into the calculus of it, but how you calculated an estimate based on those procedures.
Right. So I think one thing that's key here, most of the time, like we talked about earlier, when we estimate forage availability, most of the time we're trying to see how treatments are affecting forage availability. For my project, I was really interested in seeing how the forage that was available based on whatever a landowner was doing was going to influence the size of deer, which I think is something that we'll get into here in a little bit. But just in terms of the forage that was available, essentially what I did was go to all the properties that I had in my data set, which was again 43 sites across 25 different states. So over half the country included in that, which is kind of cool. And collected plants in various vegetation types that would have been selected by deer. And I broke the property up into discrete vegetation types, including things like closed canopy and open canopy hardwoods, closed canopy and open canopy pines, early succession, pasture, row crop agriculture, of course, food plots. So breaking it up into vegetation types that may have differences in forage based on management, and then went to each of those and collected a bunch of random forage frames at each point. And overall, just in terms of the number of species, actually had 87 different plant species and genera included that I sampled. So really, one of the big things that came out of this was just having a huge data set of deer forages collected across a bunch of different sites and seeing how, especially crude protein and phosphorus levels might compare both within the plants as well as at a more broad spatial scale.
Yeah, I've been waiting for you to drop the Oklahoma story.
About nutritional carrying capacity estimates?
Yeah.
Well, all right. Well, since you mentioned it, my first experience with nutritional carrying capacity was back in, I think, the mid to late 80s, 1980s. In
Not to be confused with the 1880s.
So we wanted to look at the nutritional carrying capacity on a property. It was a 3,000 acre enclosed property owned by the Noble Foundation, and our main cooperator there was Ken G., who's manager, the biologist over the particular property. And we collected nutritional carrying capacity quarterly over 2 years, so 8 different quarters, a lot of intensive sampling. And instead of, there's different ways you can sample the vegetation. I think the way you did it, Mark, was of forages that are known to be moderately or highly preferred. That's generally what we do with the method is sample all of them, their biomass, and look at the newer growth and the leaf material and estimate nutritional carrying capacity based on that. This was a very fine approach to it. We wanted to look at, of the forages that the deer are eating in each season, what's the nutritional carrying capacity? And to me, I've never used that method, that approach again, because I'm going to tell you why. We collected 10 adult does every season for 2 years and looked at the rumen contents, analyzed microhistologically, where the rumen contents are ground up, and look at the microscopic characteristics of the plants, and you can identify them. Then you estimate the relative composition in the diet. And then simultaneously to that, we'd have a graduate student in the field sampling the available forages on the landscape. But we only used in the nutritional carrying capacity estimate the forages that the deer were eating. And the eye-opening, like drop the mic take-home point here was the springtime had a 0 nutritional carrying capacity, when the habitat quality is probably highest of any time in the year, because you've got all this new growth. All the warm season plants are growing dramatically, and everything is high quality. We've done sampling in the early spring versus the summer in Mississippi, and seen the same species of plant, same property, drop 10 to 15% crude protein between the spring and summer. So we see these huge drops in seasonal quality that's tied back to the senescence level, or the age, kind of, the older ages, the lower quality composition. Same with deer forages. When you get too old, you get worn out and grizzly, and so deer forages they drop dramatically. And now I just rambled and missed my.
You
point.
rambled right out of your point.
Okay. So back to Oklahoma in the springtime, there was the forages that were being selected by the deer never showed up in the vegetation sampling because of the high selectivity of the deer. And that's something we preach on this podcast and many biologists do is deer are highly selective. If you diversify, if you provide them with a rich bouquet of species in the habitat that they're living in, they will find what they want and what they need when they want it and when they need it. Diversify your habitat and then let them do their job, which is the highly specialized selective foragers. So the problem is they were highly selecting low quantity forages that weren't actually sampled because they weren't as prevalent as some of the more obvious forages. And if we had tripled or quadrupled the sampling intensity, we probably could have picked some of them up. But the deer were so highly selective that we never picked up the forages. There was essentially no biomass, measurable biomass of the forages they were selecting. So nutritional carrying capacity estimates are valuable numbers. They're an index to the quality of the habitat. You have to understand what they are and what they aren't. It's like, every model, all models are wrong, but some have interpretive value, and that's the case in here. It's if you misapply it or don't apply it in the right context, you can come up with misinformation. The nutritional carrying capacity of that property was high in the springtime. It was great habitat. But we restricted the method to just the forages the deer were selectively eating, and that doomed the value. So now every time we've used it since then, we've made sure we use the same approach as you've selected, is moderately or highly preferred forages. And that doesn't mean they're not going to eat some of the unpreferred forages. And we know a lot about the anatomical and physiological control of selection. And they're going to, if they're eating a lot of high protein, they're going to have to eat some really low quality roughage forages that aren't even necessarily moderately preferred. And so diet selection is a constantly moving thing that deer do to optimize their intake to meet the requirements at a time one that they're in right now.
Okay, Mark. So essentially, why don't you tell us what you found?
Right. So collecting plants across all those sites, it was really interesting, and I think something that Steve hit on there is it's important to note here that there could be a couple of things going on, with the plants that we were collecting. So on some sites we would sample and we would not pick up that many plants that would have been selected, or at least higher quality plants. That could either be the management is such that the vegetation is not producing many, especially forbs, but in some cases it might not be producing any forage for deer. Or it could be that there were too many deer, or so many deer on the property that they were reducing forage availability. So again, the deer are influencing the amount of forage that we're collecting, which I think was a great point that Steve brought up. But across the forages that we collected, I guess the first way that I'll break this down is based on the type of plant that was out there. And so we had 3 different plant classes, and we collected young and old tissue of each of those classes. And I'm just going to share some averages just to give folks a little bit of context here. So the first one I'll start with is forbs, which were the highest quality plants that we were collecting. And on average, the young leaves of forbs were about 19% crude protein and 0.28% phosphorus. And then the older leaves were about 16% protein and 0.23% phosphorus. Now, to give a little bit of context on that, generally when we talk about lactating does, we're going to be shooting for about 14% protein and about 0.3% phosphorus on average. Now, there could be some arguments to be made about those numbers being too high or too low, but as a general rule of thumb, that's kind of what we're shooting for in trying to maintain diet quality. So both the young and the old forbs provided sufficient crude protein on average, but both of them were below that threshold of phosphorus on average, that 0.3%, and that's something I'm going to bring up several times or mention, give some more context on. The next class that we sampled were semi-woody plants, and those included vines such as muscadine, as well as brambles such as blackberry. On average, during the summer, these are providing about 13% crude protein, whether you're talking about young or old leaves, and about 0.16% phosphorus. So the shrubs, or excuse me, the brambles and vines really only have about half of the phosphorus that a deer needs to maximize lactation. And then finally, we also collected selected plant parts of woody plants, which would include young trees as well as some shrubs. And those were sitting at about 12% crude protein and about 0.15% phosphorus. So, again, you see this really dramatic drop off in forage quality between the forbs down to the semi woody plants and the woody plants. Now, that's not to suggest that semi woody and woody plants don't have value. Certainly, deer are going to use them, and in some cases, especially like earlier in the spring, they're going to provide higher forage quality than what I collected. Additionally, if you do things like implement growing season fire, of course, you can get some of that resprouting that can occur to have increases in forage quality. But just in general, again, on mostly properties that are not implementing growing season fire, you're going to see a lot lower quality of forage in those semi woody and woody plants compared to the forbs.
Yeah. So regarding your carrying capacity estimates, and we've talked a lot about that so far. But Mark, I guess what I've always thought about them as well, for some of the limitations that Steve spoke about, is it can be really good to compare, to use it like a survey or an index, to where the actual exact deer per day or days per deer, et cetera, your estimate really isn't as important to me, but it's just rather when you incorporate the same methodology, either on a site over time or among different sites at the same time, it just gives you a relative comparison from site to site.
Absolutely. Yeah, I mean it's similar to what we're talking about with female body weight. It's just an index looking at, how that forage responds to either treatments or variation in management efforts across a site. But something that was really interesting that we teased out, that I'm not aware of, at least, data collected across a large scale that has looked at this specifically. Of the forages that we collected, only 44% of the forages that, again, are quote unquote selective deer forages met that crude protein requirement. So less than half of them met that crude protein requirement. And that number actually gets worse for phosphorus. So only 19% of the forages that we collected met that minimum phosphorus requirement. Something that, you may be wondering right off the bat is, well, is this related to things like soil nutrients, variation across sites, things like that? I'm not going to dive too deeply on this, but something that Dr. Harper, as well as Bronson and several others, including myself, have been working on is kind of some analysis showing that that's not likely the case. Again, I don't want to dive too far down that rabbit hole, but this is not related to soil nutrition or anything like that. This is just simply the fact that deer have pretty high phosphorus requirements, and a lot of the plants are not meeting them.
So again, that begs the question: how do you explain what you found? And I think Steve provided a great explanation earlier. Is that maybe some of those plants, and maybe it's plants that aren't as established as we think they are as being a really, really good deer forage. Maybe they're really high in phosphorus, and maybe deer consume them all on your property. Or, so there's the vegetative side of it. The other side of it is maybe deer don't need as much phosphorus as we think they do from the very, very limited number of studies that has attempted to determine what the nutrient requirements for phosphorus are.
Right. And I think that's an important consideration. These are all indices. The big take home to me is forbs, whether you're talking about crude protein or phosphorus, they're the only ones that are consistently having a good group of them meeting those minimum nutritional requirements. And given that of the forbs, about half of them met that phosphorus requirement. I don't have the exact number with me, but about half of the forbs met that phosphorus requirement. And so managing for a diversity of forbs can be important to allow deer to select those plants, kind of like what you were just talking about, that do meet the phosphorus requirement. Most of the time, if a plant met phosphorus, actually about 87% of the time, if they met the phosphorus requirement, they also provided enough crude protein. So, typically if deer are selectively foraging for something like phosphorus, they should be meeting that crude protein requirement. But there's also this other issue of diet balancing that kind of comes into play. And a lot of these forbs also tend to be higher in things like sulfur, which, although deer have sulfur requirements, it can be toxic if they get too much of it. Now, we don't know exactly what level toxicity occurs within deer forages, but we do know that deer avoid eating plants high in sulfur. And so if that's the case, there could be some additional benefit to having a diversity of forbs that are available in a on a property, because you're allowing deer to eat the plants that are high in nutrients, as well as avoiding things like sulfur that might be toxic.
Yeah. Yeah, we don't think that there's going to be a toxicity event if a deer just eats too much of that one additional goldenrod that it ate, and a deer is going to fall over dead. But they develop what we'd call an aversion
Right.
to a particular. They're just not going to favor and consume that plant as often because of, the word, I guess, coined by Fred Provenza is the nutritional wisdom. But it's basically their body is telling them, I have excess amount of this nutrient, and I'm not going to eat forages that are very high in that. Very much like humans, the best example I can think of is salt. After you've had a really, really high sodium meal, you're not really craving to potato chips or put a bunch of salt on your French fries. You've had enough salt for the day. And we kind of think that same thing's going on with deer. Can you give some examples, Mark, of particular plants that were, to me, what I'm curious about is this particular plant was really high in crude protein, and it's probably a plant we all recognize, but simultaneously that plant is low in phosphorus, and maybe vice versa.
Yeah, so I don't have many examples of plants that were high in phosphorus but low in crude protein. But the one plant that actually was one of the most common ones, especially forbs that I sampled on this study, is goldenrod. Goldenrod tended to be relatively high in crude protein. It's not up there with some of the more annual forbs, or things like common ragweed or horseweed or soybeans, for example. But it tends to be 16 to 18% crude protein on average. But generally, it did not meet the phosphorus requirements. So I think oftentimes we think of goldenrod as a good deer forage, and it's not a bad plant. I don't dislike having goldenrod in an area, and certainly if you're allowing sunlight on the ground and you're applying fire, goldenrod is going to be some amount of the composition if you're in most of the eastern U.S. But I definitely don't want it dominant, because most of the time, for the majority of the samples, they actually did not meet that minimum phosphorus requirement, even the young tissue closer to the end of the plant that deer would select.
Very interesting. Do you remember with a plant like ragweed, or just what maybe do you recall some plants that did meet the phosphorus requirement?
Right. So common ragweed. Again, this is from a bunch of samples. I didn't have ragweed. I didn't have any of these plants I'm going to go through right here, or at least not most of them at all of the sites, but just a few examples from plants that I had at better than half of the sites that I sampled. Common ragweed, on average, was about 19% crude protein. Of course, some is going to be greater, some's going to be less, depending on how young it is. And it hit at about 0.3% phosphorus. So again, right on the nose of that minimum requirement. Horseweed is one that I've grown to appreciate a lot over the last few years. Oftentimes people think about it being a Roundup resistant plant or a glyphosate resistant plant that's a weed in crops. And in case, depending on the part of the country you're in, you might refer to this as mare's tail. And there certainly can be too much of it in some areas, but it's another really good annual species. And on average, it hit at about 18% crude protein and 0.4% phosphorus. And on a lot of the properties I saw, it was relatively highly selected. Now, I didn't measure selectivity, but just in terms of seeing deer eat it, it's not uncommon at all to see deer eat it. And in fact, it's one of those species that will that will branch out after it's foraged on, and so when you gain an eye for seeing it having been eaten, it really stands out to you. And then another one, just kind of the standard plant people think about when they think about deer management, or at least a lot of folks, would be soybeans. On average, they hit at about 28% crude protein and 0.36% phosphorus. So those are some of the better plants that were common on properties that I sampled. Conversely, if you think about other plants that were common, blackberry hits at about 12% protein, 0.14% phosphorus. So pretty low levels of both of those. Virginia creeper, on average, again, it can vary based on timing of sampling, but it's hitting at about 13% protein, 0.25% phosphorus. So it is a little bit higher in phosphorus compared to some of the other semi-woody plants, but it doesn't technically meet either of those requirements. And then if deer are really hungry and they're having to shift to eating things like oaks in the understory, which, by the way, is a huge issue in the Northeast, especially. A lot of folks are having trouble with oak regeneration in the Northeast, and deer are eating plants during the summertime that, on average, are 11% crude protein and 0.1% phosphorus. So really low quality plants. So if you're having issues with oak regeneration because of deer, that should be a sign that not only do you have too many deer, there's also just not enough forage quality out there to allow them to express their full potential, because those are not high quality forages for them to eat.
Yeah. I guess we could say too, though, Mark, we're focused on here, of course, crude protein and phosphorus. And, it's always interesting to me when you could be adjacent to a really highly productive food plot, and the trees that are on the periphery of it, you'll see the lower branches browse. Like, why in the heck, when there's this really, really good food plot, are they browsing the trees? And part of it might be, as Steve mentioned earlier, it might just be mixing. Of course, deer needing to balance out the nutrients that they're taking in. But then some of these trees, some of the older tissue can also be high in calcium. So that's like the one mineral where old tissue is better than young tissue, is they're higher in calcium. So there's so much going on. I mean, we're never going to be able to comprehend the complexity of a deer's diet. We know deer will consume mushrooms when they're available. That could be an explanation for something like a phosphorus demand, as they're consuming things that we didn't sample. But really, really interesting, the disparity here in the crude protein versus phosphorus amounts that you found. What was one more thing I wanted to ask you. Did you sample a lot of wild lettuce?
Some, I wouldn't say a lot, but we did collect leaves off of some. I don't have the value in front of me,
Okay.
but I do believe that of the plants that we sampled, and I've collected leaves off that for other projects, and it typically it definitely meets the crude protein requirements, and most of the time I've collected it also met the phosphorus.
Yeah. Oh,
Speaking of wild lettuce, that brings to mind an early study that we did back in the early 2000s, where we set up large exclosures in 3 different regions of Mississippi. And wild lettuce was pretty much only present we could only find it as a fully expressed plant within the enclosures, where deer couldn't eat it because they hit it so hard. Outside, it was just stobs of the plant where the deer had eaten it down. And to me, at the time, I was like, why are they eating that? That's just wild lettuce. It doesn't look that great. But they eat what they need to eat when they need to eat it. And we're not smart enough to know all the things that they need and want at any given time. Back to the general rule of thumb, build it and they will come. Diversify your habitat management and the quality, provide it, and they're going to work out the details. You don't have to be that smart. All you have to do is produce the habitat and let the deer figure it out.
yeah.
Another thing I wanted to ask you, Mark, you're talking about these low values in the summertime. Well, but we know, I mentioned earlier, the protein and I don't know if the phosphorus drops as much, but the protein drops significantly from the spring to the summer. Well, wouldn't an argumentative listener just say, well, my place provides all the nutrients they need in the springtime? You're just talking about the summer. Why is the summer so important?
Right. So typically, nutritional carrying capacity, at least forage quality. Obviously, the biomass is not going to be as great in the spring, but the forage quality, and thus, in a lot of cases, nutritional carrying capacity is going to be maximized a little bit earlier in the year than when we're sampling. We were really trying to do our sampling though to line up with lactation demands as well as gestation as well as antler growth, because for the most part that early spring period, although it's very important and I think shouldn't be overlooked from a management perspective, if you just had to point at one time in the year whenever forage quality really matters the most, both in terms of life history processes as well as limitations, um, the middle of the growing season is, at least to me, really where you hit on that. The demands may tend to be greater a little bit earlier in the spring. Obviously, this depends on whenever does are dropping fawns. But if we just think about something like antler growth, for example, the demands for antler growth may be a little bit greater earlier in the spring when we were sampling. The habitat conditions are going to be worse later in the summer than when we were sampling. So we're kind of hitting right there in the middle whenever we still have a pretty good amount of demand for something like antler growth, and for most of the country that we're sampling, lactation as well. But the habitat conditions aren't, right after that spring boom, whenever stuff's really, busting out and really high quality. We're sampling at that time whenever you're starting to see quality fade a little bit, but the nutritional demands are still pretty high for the deer. And so I think we're trying to kind of time it where we're hitting at both the physiological needs of the deer still being relatively high, while also seeing a time whenever habitat conditions were typically starting to decline because of that little bit of senescence of plants in the growing season.
Mm-hmm.
So, Mark, what you found here, of course, is really interesting. I think the big picture, at least for me, is one of the take homes is that diversity. Once again, yet again, you really need to provide a lot of plant diversity on your property. So here's the situation. This is kind of like a put your money where your mouth is scenario. This would not be for a private landowner where we're talking about native plants and you can either manage the habitat or you can create managed openings or whatever. You're a private landowner, you can manage the land you want to. What if you leased property? And let's just say it's a rather typical scenario to where, based on the timber or the forest on the property, you have very few openings. What most people will do is every single one of those openings, they would convert it into a food plot, which that's very good to do, of course. Do you think, based on your findings, it would be advisable to consider maybe 75% of those openings or 50% of the openings, have them in food plots as you've always done? But maybe you take some of those others and you manage it for old field. You manage the native plant community. Would you ever recommend someone taking acreage out of food plots to provide native plants?
Absolutely. Yeah, I think a lot of folks, the native forage availability is a huge limitation for deer across almost all the properties that I sampled. So I think, kind of a twofold approach would be, pulling some area out of food plot, and after you pull it out of food plot, making sure that you treat things like ryegrass that are probably there in the seed bank, as well as other non-native species that are going to be problematic. The other thing I would say would be, I did collect a lot of data off of food plots for this project. And so including some other species other than just your typical, say, oats and wheat and crimson clover, maybe. So including some later maturing clover such as arrowleaf or even red clover, as well as, potentially, on a smaller property, you're probably not going to get away with doing something like soybeans, but including some warm season food plots such as joint vetch. That really, to me, is the best thing that you could do on a smaller scale on a leased property.
Yeah. Well, Mark, thank you very much. We appreciate you spending some time with us and, of course, catching us up on your findings. They are very interesting and very relevant. So we appreciate it, man. And I know we have a little more content to cover with you as well, so we'll get to that in a future episode. But thank you for spending time with us today.
Absolutely. Enjoyed it.
Thanks, Mark.
We thank the Patrick F. Taylor Foundation and the St. John and Dudley Hutchinson families for their endowed financial support of our efforts.
We also thank our employers, the Mississippi State University Extension Service and the Forest and Wildlife Research Center. If you have questions or suggestions, please log on to msudeerlab.com and click on the Deer University tab.